let's start. Uh, Hello everyone. Today we'll be starting with Boolean algebra. So today we'll be starting with Boolean algebra, which is you can say, maybe if you remember in maths you have algebra, right? So this is algebra for digital systems, where we have variables, right? So, Boolean algebra, there are different parts of this topic. So, we'll start with the first part, which is just introducing the different laws. Or, like you have different laws in maths or physics you follow when you're solving an algebraic equation, right? So, in Boolean algebra, we have similar things, right? So, first, we'll start with first law, which we call it. Uh, Commutative law, right? So commutative, it can be applied to addition, or addition meaning your OR gate, and multiplication, meaning your AND gate. And just remember, in Boolean algebra, most of the time we only work with multiplication and addition, and we try to, it's just these two concepts only, right? So we only work with and or get most of the time. You will see more, or multiplication and addition. So the first rule says, or the commutative rule says, is the you can say is the output stays the same. Yeah, stays the same uh, regardless of how the input variables are arranged, right? So, meaning, uh, in simplest term, I'll show you, have been arranged. So, in simplest term, I can say, let's say, for example, you have uh, zoom in a bit. For example, you have a plus b is same as b plus a. You can see its positions are different, but it's still the same, right? And if you put this into a logic diagram, so it will be how. So as you can see, we are just in addition. Addition meaning it's a OR gate, right? So we say a plus b is same as having b plus a, right? And again, if you have, let's say, for example, maybe a plus b plus c, we'll still have the output the same, even if it's b plus c plus a, right? And still the output is going to be the same. So your commutative law says, no matter how you arrange your input, your output will still be the same. So we have 3 input OR gate here, so A, B, C will be the same as having again 3 input OR gate with B, C, and A. So still gives you the same. Similarly, for multiplication, if you have A times B will be same as B times A. Or if you remember in mathematics, for example, if you have 2x is still same as x times 2, right? So it's the similar, um, so we are using the similar method here, right? And then this is just AND gate, so we'll have our AND gate here. Multiplication is related with AND gate, right? And BA. So again, if we have A times, let's say C times B, is still going to be the same as uh, B, A, C. The arrangement doesn't matter because still we are multiplying all the variables, right? And that will be A, C, B is same as we have three input AND gate again, B, A, C, right? So that's your commutative law. Now we come to the next one, which we say is associative. There should be a here, law. So in simplest term, I can say associative is also can be applied to both multiplication and addition. So here, if the input variables, let's say if there is more than two input variables, the you can say the output or the result is the same regardless of you can say of the grouping of the variables. So meaning in this case it just says your output will still be the same uh, regardless of how you group them, right? Or if you're having more than two variables, and depending how you group them, it doesn't matter, your output will still be the same. So for example, we have A plus B plus C, right? And we group, let's say A plus B will still be the same as A plus B plus C if we group A and B, right? So these two, it doesn't matter how we group them, the output will still be the same, right? So how will it be the same? Or so let's say let's draw its logic diagram as well. So one of the method you can use to draw a logic diagram is work your way backward. So for example, we have A plus this whole bracket. So that plus we know it's going to be our OR gate, right? So we draw that OR gate. So we will have our A here and this will have our B plus C here, right? And then we move into this bracket. So this one will be B plus C. So that is our A input. Then we'll have our B plus C input, right? Similarly, we do the same here. We work our way back. So as you can see, we have one addition here. That's our OR gate. And that is C. Then you have these two addition, A plus B. So that will be A plus B, right? So associative law just means regardless of how you group these values, your output will still be the same. So for example, let's say if you have 2 plus 5 plus 7 and you group 5 plus 7, and it will still give you the same answer if you group 2 plus 5 plus 7, right? So the associative just mean it doesn't matter how you group them, your result will still be the same. And same goes with multiplication. So let's say again you have A times B times C. In this case, let's say you group A and B, right? Still going to be the same answer if you have again A times B times C and you group B and C, right? No, because still it's the same. If you say 2 times 5 times 7, you group 5 and 7, still going to give you the same result if you group 5 times 2 times 7, right? So associative law is just that regardless of how you group them, if and also just remember it only works if all of them is addition or if all of them is multiplication, right? So the circuit diagram will look something like this. So we work our way back. We see C times AB, so we know it's a AND gate. So we have C here, then AB, 8 times B, so we have our second AND gate here. So it's 8 times B. Similarly, you have A times BC, so our input will be A, then we'll have another AND gate, BC times A. So that will be your output, right? And still it's going to give you the same output. You say B times C, still the same as B times C. Right, because here you will have AB and you will have BC here and A here and C there. Right, so that was your associative law. Now we come to our third law, which we uh, we call that distributive law. So we call it distributive law. So in this case, it's in simplest term, we are taking out the common factor. So we take out the common factor. So we just take out the common factor, or you can say variables, right? For us, it's a variable. So taking out the common factor, meaning let's say you have something like this: a 2a plus 3ab, right? And if you want to simplify this, we take out the common factor, and in this case the common factor is a, right? So we take a out, so that will be 2 plus 3b, right? So distributive law simply means this here. You're taking out the common factor to simplify the equation, right? Or maybe let me just leave it here. So just the example, I can say you have 2a plus 3ab, then you're just taking out the common factor. Mm, 3b, right? Mm. So distributive is just taking on the common factor. So for example, if you have something like this, a b plus ac, right? And you can take here what out common factor of a, and this helps you also to reduce your logic diagram. So if your logic diagram is big, it will help to reduce the size or use less logic gates, right? In this case, how many logic gates we are going to have? If you count again, so this is how I do it. You check, okay, there is addition, so we know there is a OR gate. Then there is multiplication. We have 1, 2 multiplication, right? So we'll have 2 AND gates, right? And how do we draw this? So we work our way back. So first we start with OR gate because it's adding 2 variables already. So we have our OR gate here, right? So just remember, you can put it like this. Our output will be AB plus AC. Right, so that means one input is AB, other input is AC, right? Then we go to multiplication. So we go to this one first, AB, which is AB, it's a AND gate, right? Times A times B. So we will have our AND gate here. That will be A and B, correct? Because this output gives you AB. Similarly, you will have your second AND gate. That will be AC, right? So as you can see, we have our logic diagram. So A times B will be the AC, then you add these two together, that will be your AB, A times B plus A times C. Now this this is reduced to this one using distributive law, meaning taking out the common factor. So first we start with, so if you check uh, this bracket here, that means it's what? Multiplication, right? So multiplication is what? AND gate. So just remember, if there's bracket or anything like this, it's multiplication. So this thing is same as A times B plus C, right? So we have how many AND gates? 1, because there's only one multiplication here. Then we look at OR gate, so we see these two values being added. So there's only two values being added, so that means we have one OR gate, right? So we work our way back. So first we start with AND gate. So we have our AND gate. So this is how we start: A plus BC, A times BC. So one will be A, other input will be B plus C. Right. And where do we get B plus C? We use OR gate. So we have our OR gate going there. That is B, C. So here output will be B plus C. And then this will be A. And as you can see, we can use distributive law most of the time to reduce the number of logic gates we are using, right? So we went from 3 logic gates to 2 logic gates. Yeah. Right. So this was your distributive law, the three basic laws, just to remember, right? Yeah. So this was your three basic laws. To okay. Now again. So yeah, this was your three basic laws to remember, and now for a Boolean algebra when you will start solving, right? So yeah, cool. Thanks.